So welcome to today's Active Directory Lead webinar. It's module 5, and we're actually going to talk about a subject that is one of my favorite subjects. So this was the hardest module to write for me, because when I did it, I ended up with like a 3-day course. So I slimmed it down, and we're going to talk about the essentials. I'm going to show you some demos and how you actually can verify your replication and why things are happening as they are, and I will do live demos, so hopefully my environment is up and running. And as usual, I guess Lasse will be on the chat window answering questions, and I will do that as fast as I can as well. So let's take it away. So this picture shows the clients. Can everybody hear me besides Lasse?
Yep.
Okay, perfect. So this picture shows the client-server architecture for replication clients and LDAP clients. So the AD replication operates within the directory service component of the security subsystem. The directory service component, NTDSA, is accessed through the LDAP protocol and LDAP-C API for directory service updates, and it's implemented in the WLDAP32 DLL. The updates are transported over IP as packaged by the RPC protocol. As you know, you can use SMTP to prepare non-domain updates for TCP transport over IP. Let's see. It pinged in my window. Oh. The DRS, which is Directory Replication System, so the DRS client and server components interact to transfer and apply AD updates between domain controllers. So when SMTP is used for the replication transport, ISM served is on the source domain. Domain DC uses the CDO. CDO is Collaborative Data Object, which is a library to build an SMTP file on disk with the replication data as the attached mail message. The message file is placed in a queue directory. What happened? My screen freezed. Am I still online? Can somebody say or type something?
Yeah, sure. I can hear you. And I can still see your screen.
Okay, hang on a second.
If you move your mouse, we'll tell you what you're clicking on.
I'm waiting for my mouse to move. Okay, there we go. So where was I? Yes, the message file is placed in a queue directory. When the mail is scheduled for transfer by the mail application, which basically is the SMTP service, delivers the mail message to the destination DC over TCP/IP and places the file in the drop directory, which you can see on your left side, and that is on the destination DC. ISM serve applies the updates on the destination. And if you look at the screen, you have the replication architecture components, and I'm going to walk you through them. So you have the NTDS API.dll. That is used to manage the communication with the directory service over RPC. You have the private DRS client. That's a private version of the NTDS API.dll that runs on a DC to make RPC calls for replication. The WLDAP32 DLL, which is a client library with APIs for access to directory service. ASN.1, that is used for actually encodes and decodes LDAP requests for transport over TCP/IP or UDP/IP. DRS.IDL is a set of functions for replication and maintenance. An example of that would be get changes or get replication status. Then you have MAPI, which we all know is an entry protocol for address book applications, and an address book application would be Outlook. Then we have the famous domain rename, which actually carries out domain rename instructions. And If you remember me talking about domain rename in Norway, I hope you never have to use it. NTDSA.dll, which is the directory service module, which supports the Windows Server replication protocol and LDAP and manages partitions of data. The ISMserve.exe prepares replication data in email messages for SMTP protocol transport. CDO library, which is used by the ISMserve to package replication data into a mail message. And SMTP SVC, which basically is the SMTP service. Then besides that, we have the AD access and replication protocols. So we have the LDAP, which is the primary access protocol for AD. And we use as LDAP version 3 to connect to AD. We have IP, which we all know is a routable protocol that is responsible for the addressing, routing, and fragmenting of packets. And IP is required for AD replication. We have Replication RPC, which is DRS UAPI RPC protocol used in enabling of administration and monitoring of AD replication. To communicate replication status and topology and network topology from a client running admin tools to a DC, RPC is required. And then finally we have SMTP, which is a replication protocol that can be used by AD to replicate over IP for message-based replication. And it can only be used by sites, between sites, and non-domain replication only. So that was the replication architecture in, what, 1 minute? Oh, now I know why my screen froze. Add and pause. So the subsystem, which you need to understand, all the things we're going to do in the demos, well, of course, everything relies on what I'm saying now, but it helps you to get a better understanding. So the replication subsystem interacts with the operational layer, and you probably recognize this from the earlier webinars, which it implement replication changes on the destination DC and is placed within the directory service component. This subsystem also determines the changes that replication partner already has or those that are needed. So the database layer manages the database capability of the directory service. The ECNT DLL communicates directly with the individual records in the directory data store. So if we look at these components, we have the ntdsa.dll, short DSA, which provides the interfaces through which the directory clients and other directory servers gain access to the directory database. We have the replication, the DRS it's called. It's an interface which communicates with the database through RPC. We have the operational layer, which performs the low-level operations on the database without regard for a protocol. And we have the database layer. That's an API that resides within NTDSA DLL and provides an interface between applications and the directory database to protect the database from direct interaction with applications. And EEC, as you know, manages the tables of records, each with one or more columns to comprise the directory database. And the ntds.dit, which is the directory database file. And I went through it really quickly because I know it's a kind of a repeat from earlier sessions, but I just want to remind you about it. So if we look at the replication model and the physical structure, each component, we have a multi-master replication, we have pull replication, store and forward replication, and state-based replication. So instead of just reading it from the screen, I'm going to give you a minute to read through it. And while reading, all these mechanisms are implemented by the replication system in the sequence of events that occurs between two DCs. Okay, ready for the next slide. The component and the mechanism involved. So a very simplified replication sequence. Let's see if I can be fancy with a laser pen here. I have an originate LDAP update to a partition which increments the USN on the source DC. The next step is to identify my replication partners. I'll go through this in details as well. I will query the DNS for an IP of my partner. I will send a change notification to the destination. We have mutual key-based authentication, of course. On the destination side, I realized that, okay, I want this update. So I send a request for changes, including all the metadata that I need to know what to change and if I should change it. So I send it back. It acknowledges it and sends the updates to the destination. This is not 100% true. It's actually pull, but this is how Microsoft wants us to tell you. So I use the Replication Subsystem and applies the updates to the database. So that's a very simplified version of it, but that's how it goes, and it's not that hard to see the logic behind it. So, data updates. When a change is made to an object in directory partition, the value of the changed attribute or attributes must be updated on all DCs that stores the same replica. And you know that all DCs do not necessarily have the same replicas, for example, an application partition. So it's not true in all cases that you give all the information to all DCs. And the DCs communicate the updates automatically through AD replication. The communication about updates is always specific to a single directory partition at a time. AD objects are instances of schema-defined classes, which consist of name sets of attributes. Schema definitions determine whether an attribute can be administratively changed. Attributes that cannot be changed are never updated and therefore never replicated. Okay. So attribute changes. AD updates originate on one DC, and that is called originating updates. And keep that in mind because I'm going to come back to that word many times. So originating updates, and the same update is subsequently made on another DC during the replication process. And that update is called replicated updates. So object update behavior is consistent and predictable. When a set of changes is made to a specific directory partition replica, those changes will be propagated to all other replicas of the directory partition. How soon the changes are applied depends on the distance between the DCs and whether the change must be sent to other sites. There are some key points that are central to understand the behavior AD updates. First of all, changes occur at attribute level. Only the changed attribute value is replicated, not the entire object. And that is true depending on the first functional level, 2003 or higher. At the time of replication, only the current value of an attribute that has changed is replicated. If an attribute value has changed multiple times between replication cycles, only the current value is replicated. The individual values of multi-valued attributes are replicated separately if the forest functional level is Windows 2003 interim or Windows Server 2003 and the attribute is linked, and above, of course. You have to note, and this is important, that linked attributes have the following characteristics. The attribute is multi-valued. The attribute has the DN syntax. The attribute is marked as linked in the schema. So an attribute is available for replication as soon as it is written. Replication is stored and forward and moves sequentially. Multi-master conflict resolution is effective without depending on clock synchronization. Originating updates to a single object are written to the database in the same transaction. This means that partially written objects are not possible, and a consistent view and a consistent view of the object is maintained. So either everything is written or nothing. And you also understand that for replicated updates to a large number of values in linked multi-valued attributes, for example, the member attribute, updates are not always guaranteed to be applied in the same transaction. After replication cycle is initiated, all available changes to a partition on the source DC are sent to the destination DC, including changes that occur while the replication cycle is in progress. So let's see the effect of schema changes. Attribute definitions are stored in attribute schema objects in the schema directory partition. Changes to attribute schema objects block other replication until the schema changes are performed. During replication of any partition, of course except the schema partition, the replication system first checks to see whether the schema version of the source and destination are the same. If the versions are not the same, the replication of the other partitions is rescheduled until the schema directory partition is synchronized. So the schema partition is always most important. Replication of multi-valued attributes after schema change. Well, basically, it's the smallest change that can be replicated is a separate value in a multi-valued attribute that is linked. That's pretty easy. So let's look on linked and non-linked attributes after raising forest level. A linked attribute represents an inter-object distinguished name reference with multiple values. For example, the member attribute of a group object can have multiple values of username, computer names, and other groups. The member of attribute of a user, computer, or group object can have multiple values of more than one group name. The relationships between a group and its member are stored in separate table in the directory database as link pairs. Because the member and the member of attributes are linked in the database and indexed for searching, the directory can be examined for all records in which the link pair is member/member of, and the member of attribute identifies the group. So changes to certain multi-valued attributes, those that have the distinguished name values and are also linked, can be replicated on a per value basis instead of the entire attribute being replicated. This type of replication is called linked value replication, LVR. This feature is most significant where group membership is a concern. So my tip is to do not do more than 5,000 updates to a single object because LDAP have a practical limit of the number of updates that can occur in a single transaction. And another thing that you need to be aware of is only originating updates must be applied in the same database transaction. Replicated updates can be applied in more than one database transaction. And when you raise the forest functional level to enable linked value replication, you have to remember that it's not automatically converted. So, for example, if you have a very large group, let's say an environment that was created on Windows 2000, and you have a really, really big group with 4,000 users, for example, and you raise the forest functional level when you get to 2003, 2008, or whatever, that doesn't automatically convert to linked value replication. You have to modify each of the members in the group, and that will, when you do a repadmin/show object meta server name object or group name, you will see the members, and it will have they will be marked as a legacy, and I will show you this in a few minutes. So just by raising the forest functional level doesn't mean you're actually using LVR. That's what I'm saying, bottom line. Originating updates. As an LDAP directory service, AD supports the following 4 types of update requests: add an object to the directory, modify attribute values, move an object by changing the name or the parent of the object, and delete an object from the directory. Some of them are actually just specialized modify operations that you'll soon see. So each LDAP request generates a separate write transaction. An LDAP directory service processes each write request as an atomic transaction. That means that the transaction is either completed in full or not applied at all. The practical limit to the number of values that can be written in one LDAP transaction is basically 5,000 values, added, modified, or deleted at the same time. A write request either commits or it fails before completion and has no effect. A write request that commits is called an originating update. An originating update is initiated and committed at a specific replica. The absolute success or failure of an update applies even for requests that might affect several attributes of a single object, such as add or modify. In this case, if one attribute update fails, they all fail, and the object is not updated. An easy way to see this in practice is actually to create a new user. And when you come to set the password for the user, and if you type a password that is not compliant with the password complexity policy, the user will actually be discarded and deleted. You can see it in the deleted objects container. So when you go back and try to retype it and type a non-compliant password again, it will again, that user will be deleted, and you retype the password and you type it correctly this time, the user will be created. So that's a very easy way to see how originating adds works, and everything has to be committed. So a little more about originating add. An add request makes a new object with a unique object GUID attribute. The values of all replicated attributes that are set by the add request are stamped version equals 1. The add request fails immediately if the parent object do not exist, or if originating DC does not contain a writable replica of the parent object's directory partition. So let's look at originating modify. All modify operations replace the current value of an attribute with a new value. A modify request can specify one of the following: that an attribute be deleted from the object. Think of attribute deletion as replacing the attribute value with null. The null value occupies actually no storage, but they do carry a stamp. The other one is that the value be added to the current value of an attribute, as when modifying an attribute they can have multiple values. The effect is to replace the current values with the current values plus the added value. So for each attribute in the request, a modify request compares the new value in the request with the existing value. If the values are the same, the request to modify that attribute is ignored. If the resulting modify request does not change any attributes of the object, the entire request is ignored. Otherwise, a modify request computes a stamp in the metadata for each new replicated attribute value by reading the version from the existing value, version equals 0 for an attribute that has never been written, and then adding 1 to this value. The modify request replaces the old stamp values with the new stamp values. Get some water. Originating move. A move request is essentially a special modify request that does the following series of operations. 1. Sets the isDeleted attribute to true, which makes the object marked as a tombstone. 2. Changes the relative DN of the object to a value that cannot be set by an LDAP application. 3. It strips all attributes that are not needed by AD. A few important attributes, which is, let's see, object GUID, object SID, DN, anti-secure descriptor, and use unchanged, which will be preserved on the tombstone. And lastly, it moves the tombstone to the deleted objects container. So when I said strips all attributes that are not needed by AD, that is only true if you haven't enabled the recycle bin. There are controls which you can set with ldp.exe to say, even if I delete this object, please, or actually you force it to, what do you call it? Lost for words. It will keep the attribute values. So there's just you fire up LDP, you set a certain control on an attribute, and it will be kept even though it's in the tombstone. It's tombstone. So protected objects can actually become deleted, and that's when the DC that stores them is demoted, and that's the only way. Replicated updates. A replicated update is performed on one domain controller as a result of receiving replication of an originating update that was performed at another DC. There is not necessarily one-to-one correspondence between originating and replicated updates. A single replicated update might reflect a set of originating updates to the same object. Replication of absent linked object references. A different condition occurs when the object that the link refers to is simply removed as a referent, as when a user is removed from a group. The user value is marked absent in the database so that its condition can be replicated, much like Tombstone actually. The deletion of the user object from the group replicates as an absent value in the member attribute of the group. After Tombstone lifetime, absent values are physically removed from the database, but until that time the link value remains in the database, which will give you a great opportunity to see, during the Tombstone lifetime of course, to see if somebody has been removed from a group, for example. Update tracking. AD replication does not primarily depend on time to determine what changes needs to be propagated. Instead, it uses USNs, which is update sequence numbers, which are assigned by a counter that is local to each DC. Because these USN counters are local, it is easy to ensure that they are reliable and they cannot decrease in value. An important thing, replication uses Kerberos version 5 for security, which does require that the time service on a DC are synchronized. When a conflict occurs, AD uses volatility, which basically means number of changes, as the first element of the per attribute stamps that are compared during conflict resolution. And I will show you this in real life later. The second element is a timestamp. Therefore, if an attribute is updated once on a DC, on DC A, and once on DC B, the last writer's update is preserved. But if the attribute is updated on a DC A and then on DC B, and then again on DC A, the update of the DC A is preserved even if the clock of DC B is set forward from that of DC A. How to determine changes to replicate? Well, basically update sequence numbers. A source DC uses USNs to determine what changes have already been received by destination DC that is requesting changes. The destination DC uses USNs to determine what changes it needs to request. The current USN is a 64-bit counter that is maintained by each AD DC as the highest committed USN attribute on the root DC object. At the start of each update transaction, the domain controller increments its current USN and associates this new value with the update request. The current USN value is stored on an updated object like this. It's two things. Local USN. The USN for the update is stored in the metadata of each attribute that is changed by the update as the local USN of that attribute. This value is local to the DC where the change occurs. The second one is USN changed, which has a maximum local USN among all of an object's attributes is stored as the object's USN change attribute. The USN change attribute is indexed, which allows objects to be enumerated efficiently in the order of their most recent attribute rights. Note, if your forest functional level is 2003 or 2003 interim, discrete values of linked multi-valued attributes can be updated individually. Of course, everything newer than 2003 this applies to as well. In this case, there is a USN change associated with each link in addition to the USN change associated with each object. Therefore, updates to individual values of linked multi-valued attributes do not affect the local USN. Only the USN change attribute on the actual object. So the originating USN, for an originating write only, the updates USN value is stored with each update attribute as the originating USN of that attribute. Unlike the local USN and USN changed, the originating USN is replicated with the attribute's value. The destination DC use the originating USN to track changes they have received from other DCs, which they replicate. And I will show you this during the live demo as well. When requesting changes from a source DC, the destination informs the source of the update it has already received, so that the source don't replicate changes that the destination doesn't need. So I have two values actually that are used by source and destination DCs to filter updates when the destination requests changes from the source replication partner. These two values are called, the first one is called up-to-dateness vector, which is the current status of the latest originating updates to occur on all domain controllers that store a replica of a specific directory partition. The second one is high watermark. Some books and white papers are referred to it as direct up-to-dateness vector, but high watermark is what I use and 90% of the world use. The latest originating update to a specific directory partition that has been received from a specific source during the current replication cycle. And I will show you this in an animation to make it easier to understand. So, and you also need to know that both of these values specify the invocation ID of the source domain controller. Attributes assigned for replication, up-to-dateness vector. The up-to-dateness vector is a value that destination DC maintains for tracking the originating updates that are received from all source DCs. When a destination DC requests changes for a directory partition, it provides its up-to-dateness vector to the source DC. The source DC uses this value to reduce the set of attributes that it needs that it sends to the destination DC. The up-to-dateness vector contains an entry for each DC that holds a full replica of the directory partition. The up-to-dateness vector values include the invocation ID of the source, the highest originating write that it has received from the source. If the up-to-dateness entry that corresponds to source X contains USN N, the destination DC guarantees that it holds all updates to a specific directory partition that originated at the domain controller X and that have an originating USN value of less than or equal to N. If the destination already has an up-to-date value, the source DC does not send that attribute. After the completion of a successful replication cycle between two replication partners, the source DC returns its up-to-dateness vector to the destination, including the highest originating USN on the source DC. The destination merges this information into its up-to-dateness vector. In this way, the destination tracks the latest originating update it has received from each partner, as well as the status of every other DC that stores a replica of the directory partition. Timestamp and up-to-dateness vector. On domain controllers that are running 2003 or later, the up-to-dateness vector includes a timestamp that represents the last time the local destination DC has completed a full replica cycle with the source DC. The replication cycle may have occurred directly or indirectly. The timestamp is recorded whether or not the local DC actually received any changes. By examining the timestamps, a DC can quickly identify other domain controllers that are not replicating. Warning messages will be posted in the event log on each DC if or when non-replicating partners are discovered.
Jimmy?
Mm?
I'm not sure we can see your updated screen because we're still on the data update slide.
That's where I am.
Okay, because you're showing an animation, or we didn't see
I will come to the animations later.
Okay,
great. I'm just walking through this.
Then we are on track.
Okay, perfect.
Thanks.
So conflict resolution, which is the last one, they must ensure that all DCs agree on the value of the updated attribute after replication occurs. The general approach to resolving conflict is to order all update operations, which were add, modify, move, and delete, by assigning a global unique per object and per attribute stamp to the originating update. Thus, each replicated attribute value or multi-value is stamped during the originating update, and this stamp is replicated with the value. When stamps are compared, the version is most significant, followed by the originating time and then originating DC. So if you use the command repadmin/show_meta, you will see all the three things here. So I talked about groups. This is repadmin show_object_meta, which DC I'm asking, and the group name is OU admins. I can see originating DSA, which is demo DC1, the local USAN, the original USAN, the time, and date, or date and time. I see the version numbers. I see the attribute which is populated. And since this is a group, it will also show me the members. So I am present, Jimmy Anderson. Carola Anderson is present, which means currently a member of that group. I see Wilma Anderson used to be a member of this group, which you can see absent. And since the first version, version 1, is me being added to the group, the second action I did on Wilma in this case was to remove her from the group. That's why version number is 2. So, destination identification of source and source identification of destination. So, as I said before, replication occurs between 2 or more DCs at a time. The replication topology determines the replication partnerships between source and destination DCs. As a replication source, the DC must determine the replication partners. It must notify when changes occur. And if you remember the picture I showed you, the simplified with blue DCs, source and destination, this is actually what I'm going through now, talk about now, how they actually identify each other. Let's see. So destination identification of source replication partners. And as you remember, we talked about KCC before. When the KCC creates a replication topology, it creates connection objects on destination DCs that represent the inbound connection from the replication source DC. For each source DC that is represented by an inbound connection object, the KCC writes information to the reps from attribute of the directory partition object for each directory partition that the destination domain controller has in common with the source domain controller. This information is local to the destination DC and it's not replicated. For destination DC, the reps from attribute contains the following information about each source domain controller: directory partition name, entity settings object, GUID-based DNS name, CNAME alias, whether replication is intrasite, intersite using IP or SMTP, flags that actually governs the options, which indicate whether notification is allowed or not. It has information about the invocation ID, direct USN vector or high watermark, time of last attempt and time of last success, lost error code, and count of consecutive failures, if any. So if you have run rep admin show REPL, and if you have some replication error, on the bottom line it will tell you 8 errors couldn't replicate or whatever. That's the count of the consecutive failures. It can easily be removed by emptying the event log. If notification is enabled on the destination DC, the destination responds to the notification message from the source DC by sending a request for change. If notification is not enabled, the destination responds to notification request with an error. Notification is enabled on the destination DC except under the following condition, in which KCC sets the option never underscore notify in the reps from. The conditions are: the connection object that the KCC creates is inbound from a server in a different site. The connection object is created to identify the source from which this DC replicates to add AD as a new domain controller. So, source identification of destination replication partners. The source DC keeps track of the replication partners that pull changes from it and uses the information to locate partners for change notification. This information is not provided by the KCC, but rather by the source DC itself during a replication cycle. The first time a DC receives a request for a change from a new destination, the source creates an entry for the destination in the reps2 attribute on the respective directory partition object. When the source has changes, it sends a notification to all replication partners that are identified in the reps2 value for the respective directory partition. Like the reps from data, this information is stored locally on the DC and it's not replicated. When updates occur, the source DC checks the reps2 attribute to determine the identities of its destination replication partners. The source DC controller notifies them one by one that changes are available. If a destination DC has the never notify option set, the destination responds to a notification message with an error. When the error is received by the source DC, it removes the entry for that destination from its reps2 data. If a destination domain controller moves to a different site, the KCC adjusts the notify setting to indicate that notification is not needed. So let's give you an example where you actually want to use notify or don't notify. Let's say you have 2 sites and you want to have immediate replication between the sites. You go to the site object and you enable change notification. So the DCs between the sites actually behaves from a replication perspective like they are sitting next to each other in the same site. Short summary: USN update sequence number is associated with replication operation, assigned transactionally, 64-bit integer. Each DC maintains its own USNs. Each object carries 2 USNs, USN created, USN changed. Each attribute carries 2 USNs. So let's look at the USN numbers. So I have DC1. I'm going to create a new user. So my local USN, which was 4710 before I created the user, is now 4711. So if you look at the table, we have USN created 4711, USN changed 4711. We have populated these attributes. They have a value. Each attribute has a USN number associated to it. We have a version number, timestamp, originating GUID, which is where did I actually create it, since it was in DC1, DC1 GUID, originating USN 4711, which is corresponding to that. So I replicate the user. Before the user arrives, I have USN 1745. When the user has been committed, I increase the USN to 1746. If I look at the table, USN created 1746, USN changed 1746. I have my new USN local on the DC2, 1746. It's the first version on this DC. I have a timestamp. Originating GUID says, oh, it's DC1, so this is something that replicated in. And the originating USN 4711, which comes from DC1. what happens when I modify something? So let's say on DC2 I changed the address. Locally, I increased my USN number. So when I look at this on DC2, USN created 1746. I changed an attribute, which I increased my USN to 1747. So USN change becomes 1747. I look at the table. I change the value, in this case the email address. That USN for that attribute is increased. It's the second version, gets a new timestamp, and it tells me DC2 did the originating right, and the original USN was 1747. So I replicate it to DC1, increase the local USN, look at the table, and the address value is increased to 5040. It's the second version on this domain controller, gets a new timestamp, and the change was on DC2, and the originating USN was 1747, which is up here. So you see USN created 4711, USN changed 5040, and that's how it actually tracks it. Demo. So what I'm doing here is I'm using the old-fashioned repadmin / show object meta, tells which DC I want to question, and this is my user. So this is exactly what I did in the showed in the PowerPoint slides. So I have my local USN, originating DSA, and this is the attributes. So everything was done on DC1 except the mail attribute. So I didn't have a mail attribute when I created the user because I see this is the first version, you see it here, and it was done on DC2. But when I see the object class, that tells me where I created the user, and I can go through, I can see I changed the password last set, I've done that 3 times, and so on and so forth. So that's let's see. So let's do another demo of the things we've seen. So I created a lead and test. We're going to see we have it on here as well, lead and test. And I'm going to put this on pause to create a simulation of a non-working replication. Let's see. What happened here? Hello. So let's call him test 10. Let it replicate, and on the last slide in this slide deck, I have all the commands I'm using is in the notes field. So repadmin sync all ADEP, case sensitive, means I'm going to sync all my partitions across the enterprise with push. If you have a big environment, be careful. So we have test 10. So let's pause this. Let's go here. We're going to do some change now to objects. For example, reset password. Let's look at first here. Was in lead test. Test equal lead and so you see everything is on DC1 now, and and we have password last set 5 because I mistyped the password the first time. And I'm looking at the test 10 user. It's the 5th version, the time, the originating user, which DC, and the local user. So let's replicate it to this one. There we go. And we want to changes. And I remove the /p, which means I will pull the changes instead. See, now you can see that my password last set is 7, the version number is 7, the dates, the original user, where I did it. I did it on DC2, and the local, which is local on DC1. I also did mail, which is the first version, at this time on Uppsala demo DC2. So it's an easy way to, and a quick way to see where did, because usually you get a call saying somebody changed something, go figure it out. And you using this, you will actually see on which DC the change occur. And if you configured the event log and auditing correctly, you should be able to go to the event viewer and find out who actually did it. So this is a good way of tracing it back. So the other one I'm going to do is, let's pause 2 again. And we create, this is to show you some conflict things. Finish. Pause. I'm now just preparing to give you that. Just 20. And that will take some time because the PDC emulator is not available. So let's go back to the slides. I told you briefly about high watermark vector table before. Just a recap, it's a table on each DC, replication partner's highest known USN, used to detect recent changes on replication partners. And it's actually pinging between DCs every hour. You can configure it. So this is how it looks like. So every DC knows about their replication partner. DC2 is a replication partner and DC3 is a replication partner, and their USN, and so on for the rest of the 4 DCs. Up-to-dateness vector. It uses propagation dampening, which prevents the same piece of information from being replicated more than once. Table on each DC, originating DC grid, highest originating right USN. Only DCs issuing originating rights are added, related to specific naming context. And it looks pretty much the same. So how would it look in real life? As I did and showed you in the environment, I added a DC. So I get a new USN number. I notify. I send back the metadata to compare what do I need. I get the user, and I update high watermark and up-to-dateness table, because now I know you're up in 116. Same here. Replication continues. Updates. And there you go. We have a full replication circle. So propagation dampening. What happens when DC3 from DC3 to DC4, it will try to notify you, say, hey, I got an update. It will compare and it will break on up-to-dateness. Stop, I will not replicate that, because what I know about you is this. Conflict resolution, this is for you to read more on, but you will see it soon. So attribute value, conflict resolution. If I change the passwords, it goes to version number, timestamp, and grid of originating DSA. Move under deleted OU. It will be moved to lost and found. Object name creation, which was the demo I prepared, which I will show you in 1 minute. I know I'm actually on doing. So let's start that. Just want to show you in real life how it looks like. So let's push, get in. If you remember, I created test 20 on each DC while they were not in connection with each other. So as the slides showed, we have 2 RDNs that are the same. The only way for AD to make you aware of it, it's creating a CNF object on one of them. So you need to manually go in and figure which one do I really want to use. So let's do the last thing. We go down. We change. There you go. And we pause this one. I'm going to move this user to delete. But before I do, I'll pause this one. Now pause this one. Hopefully I post it on time, yes. So what I'm simulating is the move under deleted OU. Deleted. It's lost and found. And to see lost and found, advanced features. That's how that works. Because AD do not know, because the parent is gone, so it moves you to lost and found. And on this slide, I gave you some nice, cool things, and this is the one I use the most. Hello. Why can't I just copy? How can't I? Yeah, never do live demos. This one instead. I just want to show you how to combine old-fashioned things with new stuff. I never remembered in my head. Convert from CSV out quickly. So I'm combining the old repadmin with PowerShell to make it more clearly than just using repadmin. So all those are some tips and tricks on the last slide in the notes section. And by that, I say thank you and sorry that I took 5 minutes of your time. Over time.
Great, Jimmy. It was interesting.
I told you I can do 3 days on this.
Yes, I bet you can. And we will continue on the Exchange track. And our agenda states that Lasse will talk about the Exchange Server Management Shell. We have a separate meeting for that, so make sure you are joining the correct meeting. We will rejoin in 25 minutes, 10:30, and Lasse will take us away on the management shell. So thank you all, and
Thank you.
Yep.